Hello, Algebra 2 folks, and welcome to Evaluating Trigonometric Functions of an Angle. You need your notes, a pen or a pencil, and a calculator. We're going to start off by talking about a couple of new definitions that you've never heard before, a reference triangle and a reference angle. So the idea comes from us drawing our angles that we learned how to do yesterday. So we always start at the initial side, which is 0. And to draw any angle, if it's positive, we go counterclockwise, and if it's negative, we go clockwise. So let's just say we're going to draw an angle that's positive, okay? So this would be a positive angle somewhere between 90 and 180, because this is where 90 degrees is, this is where 180 degrees is. This is the initial side, remember, and this is the terminal side, because this is where it ends. If I want to draw a reference triangle based on the angle I just made, it is the triangle that's created when you draw a line from the terminal side. So the terminal side is your hypotenuse of your triangle, and you are going to drop a perpendicular. Perpendicular means a 90-degree angle to the x-axis. Now that's really important that we never drop a perpendicular to the y, we always drop it to the x, and we form our reference triangle. This would be a reference triangle. So it has the terminal side, the x-axis, and a 90-degree that's dropped, a perpendicular that's dropped from the terminal side to the x-axis. That is called the reference triangle. The reference angle is the angle that is closest to the origin inside the reference triangle. So this is the origin, 0, 0. This would be your reference angle. Okay? So we have reference triangle and we have reference angle. Those are going to be two very important definitions in slides to come here. All right, let's practice what I'm asking you to do here, but using actual numbers. So let's sketch an angle, and let's make the reference triangle, and then I want you to identify the reference angle, not just where it's at, but the actual degrees. So the first one I want to do is 210. So I'm going to draw a 210-degree angle. Okay, that would be somewhere about there, a little bit more than 180. Okay, and this is 0. And I'm going to draw my terminal side here, and I'm going to say this is 210 degrees. Now what I want to do is I want to be able to draw my reference triangle. So my reference triangle always has my terminal side, and I always drop a perpendicular to the x-axis. Well, this is the x-axis, so I'm going to drop a perpendicular, and there is my reference triangle right there. So that's my reference triangle. Now I want to find my reference angle. Now I know that my reference angle, I just told you that my reference angle is closest to the origin. So this is my reference angle. But what I want now is I want to know what that degree is. So what we do is we always take 210, our angle, and we always subtract the closest degree. So the closest degree would be 180. So I'm going to take 180 and subtract that from 210, and I get 30 degrees. So this reference angle is a 30-degree angle. Okay? Let's try it again over here. So now I want to do a 110-degree angle. So I'm going to start at my initial side of 0. I'm going to go past the 90, a little bit past the 90, about right there. That would be 110. Draw my terminal side, okay, and then I need to draw my reference triangle. So I take my terminal side, the x-axis, and I drop a 90-degree from the terminal side to the x-axis. I have my reference triangle, Now I want to find my reference angle. Now my reference angle is here, but I want to actually find out what degree that is. So using the 180 x-axis there, I'm going to take 180 minus 110, and I'm going to get a 70-degree reference angle. Okay, let's try a couple more. Negative 130. So first I'm going to draw my negative 130-degree angle. That means I'm going to go clockwise 130 to here. That's a negative 130-degree angle. I've got my terminal side. Now I take my terminal side and my x-axis and drop a perpendicular. Always dropping a perpendicular from the x-axis, not the y-axis. Okay, this is the x. Now, I know that that's 100, and if I go all the way, that would be a negative 180, right? So the difference between 180 and 130 would be a 50-degree reference angle. So this would be a 50-degree reference angle. Okay, let's try negative 295. So start at my initial side, go down, down 295. So I want to go all the way around to about right there. Okay, this would be a negative 295-degree angle. All right, now what I want to do is make my reference triangle. Remember, my reference triangle is always my terminal side, drop down a perpendicular to my x-axis, making a 90-degree. And then this angle right here is my reference angle. So if I went all the way around, I would have went 360. So if I take 360 minus 295, I would get a 65-degree reference angle. So my reference angle there is a 65-degree angle. All right, let's try a couple different kinds of problems here now. These ones say sketch the angle and the reference triangle and the reference angle. However, it looks like these guys aren't degrees to start out with. They are radians. So what we must do is convert to degrees first. And that's why we learned how to convert from radians to degrees and degrees to radians. So I need x degrees over 360 is equal to 5 pi over 3 over 2 pi. Cross multiply 2 pi x equals 360 times 5 over 3 is 1800 over 3, which is 600. Divide by 600 pi, divide by 2 pi, and I get x equals a 300-degree angle. So I need to make a 300-degree angle. So that's going to take me all the way to here. I do my terminal side, and then I have to make my reference triangle, which is x-axis, terminal side, dropping a 90-degree angle, and then that angle right there is my reference angle. We know we went 300 degrees, so we're going to go to the closest x-axis is 360. 360 minus 300 is 60-degree reference angle. So right in there would be a 60-degree reference angle. Okay, got to do the same thing with negative 7 pi over 9. So I've got to take x over 360 equals negative 7 pi over 9 over 2 pi. I'm going to cross multiply. 2 pi x equals negative 7 ninths times 360 is negative 280 divided by 2 pi. And I get x equals a negative 140-degree angle. So I'm going to draw a negative 140-degree angle. So I'm going to go clockwise because it's negative. 140, that puts me about right there. I'm going to draw my reference triangle. My reference triangle is to drop a perpendicular. Ooh, that was a really bad perpendicular. My apologies. Let me see if I can draw a better perpendicular there. Perpendicular down to my terminal side, making a 90-degree angle using my x-axis. There's my reference triangle. And my reference angle is going to be 180 minus 140, which is a 40-degree reference angle. Our reference angles are always going to be positive. They're never going to be negative. Okay, so that is the end of that, but we have a little bit more left to go here. Now that we understand the reference angle and the reference triangle, we can now evaluate the 6 trig functions for a triangle being created. So we're always going to draw the line to form the triangular perpendicular, that perpendicular from the x-axis. So remember, always do the terminal side down to make the perpendicular. Now what we can do is I can give you an ordered pair, and if I give you the ordered pair, I know certain sides, because if I have horizontal and vertical lines here, then I know that I know those units. And by knowing those units, then I can evaluate my 6 trig functions. All right, so now what we need to do is we need to be able to evaluate my 6 trig functions of theta given a point. So the first thing I need to do is I need to be able to find that point in -4, 3. Well, -4, 3 is right here. That's -4, 3. Now, it says it's on the terminal side. So if it's on the terminal side, I know that that point is going to go through the terminal side of my angle. So my angle is actually this angle right here. Now I don't know the degrees, but I do know that that's the angle that I'm drawing. Okay? Now, I also know I can drop a perpendicular down from the point and to the x-axis, and I can identify that this is -4, 3, which means my x value is -4 and my y value is 3. Now, if I know my x value is -4 and my y value is -3, I can find my hypotenuse. So that would be a squared plus b squared equals c squared. Make sure you square that negative, otherwise everything will be thrown off. So this would be 9 plus 16 equals c squared, 25 equals c squared, c would equal 5. That's always going to be a positive number. Your hypotenuse is always positive. Okay, so now I know my hypotenuse is 5. Well, if I know my hypotenuse is 5 and I know that this is my reference triangle, I know that this angle right there is my reference angle. That means that's where I'm standing with my smiley face. So from there, I should be able to identify these 6 trig functions. Remember, sine is opposite over hypotenuse, so that would be 3/5. Remember, cosecant is the inverse, so that would be 5/3. I can do cosine, which is adjacent, which is -4/5 over hypotenuse. And I know cosine and secant are inverses of each other. So it would be 5/-4. And then I know that my tangent is TOA, O/A. So O, opposite is 3, A is -4. So then I know that cotangent is inverse of that, which would be -4/3. Okay, let's try that one more time here. This time my point is -3, -3. So let's go ahead and draw a coordinate plane. Okay, find where 3, -3 is. So there's where 3, -3 is. The terminal side of the angle goes through that point. Okay, and then from there I can make a reference triangle, drop down my 90. Okay, there's my reference triangle. It is exactly 3, and this is my -3, and I have to find my hypotenuse. And I know that my reference angle is right there. That's where I'd be standing once I find my hypotenuse. Now this is a 45, 45, 90 triangle because 3 and 3 are the same. And 45, 45, 90 triangle, just remember, is hypotenuse is equal to side times the square root of 2. So this would be 3 times the square root of 2. You could also use the Pythagorean theorem. I like to use my 45, 45, 90 rules and 30, 60, 90 rules when I can. Makes things a lot quicker and faster. So that would be 3 square roots of 2. And remember, the hypotenuse has to be positive. All right, so now I can do sine. Sine is opposite, which is -3 over 3 square roots of 2. Before I rationalize that denominator, I'm going to go ahead and make my cosecant, because that is the inverse, which is 3 square roots of 2 over -3. And now I'm going to go ahead and reduce and simplify this and get rid of that radical on the bottom. So 3 and -3 cancel to make -1 over the square root of 2. So what I can do now is multiply the square root of 2 on top and the square root of 2 on bottom. I get negative square roots of 2. 2 times 2 is 4. The square root of 4 is 2. That would be my sine. My cosecant, I can simplify the 3 and the -3 by saying -1 square roots of 2. All right, now I can do cosine, which is adjacent, which is 3 over hypotenuse. Same thing, I'm going to go ahead and do my secant, 3 square roots of 2 over 2. I'm going to then go ahead and simplify this because 3 and 3 cancel to make 1 over the square root of 2. Multiply the top and the bottom by the square root of 2, and I get square root of 2 over square root of 4, which is 2. I can simplify the 3 and the 3 here on my secant, and that would be the square root of 2. And now all I have is my tangent. My tangent is O over A, which is -3 over 3, which simplifies to -1. And my cotangent is inverse of that, which would be 3 over -3, which also turns out to be -1. All right. So now, hopefully, you understand what reference triangles are and reference angles and how we can evaluate trig functions based on an ordered pair. We'll see you back tomorrow to practice this. Thank you for taking good notes, and have a great weekend.